Assalamualaikum warahmatullahi wabarakatuh, and hi everyone, it's me again. Let's continue with the second subtopic for hydrostatic, which is on fluid force, or also known as hydrostatic force. At the end of this lecture, you should be able to identify and illustrate the forces acting on hydraulic structures and formulate and apply the concept of hydrostatic pressure to solve problems when the hydrostatic force is exerted on plane and curved surface under static condition. Important principle for you to solve equations related to hydrostatic force on plane surface and inclined surface is that there is no shear stress present when the fluid is not in motion. So bear in mind, hydrostatic meaning that our liquid is not moving, so there will be no shear stress present. And the pressure exerted by a fluid under hydrostatic condition at any depth is equal. The pressure acts perpendicular to an immersed surface, and the hydrostatic pressure varies linearly, increasing with an increase in depth. Let's look at this here, a plate, for example, gate valve in a dam, or the wall of a liquid storage tank is subjected to fluid pressure distributed over its surface when exposed to a liquid. We need to determine the magnitude of the hydrostatic forces and its point of application, which is called the center of pressure. Okay, so when we have problems related to hydrostatic force, we need to determine the value of hydrostatic force, and also we should know where the hydrostatic force will act. So that point is known as the center of pressure. So these are the examples of pressure variations on submerged rectangular plate. So the equations to determine the resultant force is shown here. So this is how we can determine if the plate is placed horizontally, vertically, and also tilted. Okay. Let's derive the formula to determine the hydrostatic force. Consider a plane surface is immersed in liquid, inclined at an angle theta from the free surface. So refer to the diagram. G here represents the center of gravity or the centroid of the plane. Cp is the center of pressure, or where the point where the hydrostatic force will act. Hg is the locations of center of gravity or the vertical depth, yeah, of the center of gravity from the free surface, while Hp is the vertical depth from the free surface to the center of pressure. Consider an elemental strip where the pressure P is constant and the elemental force dF acting on the elemental area dA can be written as this: rho g H dA. Integrating delta F over the entire immersed surface will give the resultant hydrostatic force. F is equal to this, and the integral expression in the above equation is the first moment area of the immersed surface about the water surface, which is AHG. Thus, we can obtain the hydrostatic force equations of F is equal to rho g AHG, where rho is the density of liquid, g is the gravitational accelerations, a is the surface area, and hg is the vertical distance from the free surface to the centroid. Remember, F will act normal on a single point on the immersed surface, that is the center of pressure. Hg is measured vertically from the free surface to the submerged area, center of gravity, and A is referring to the submerged area of the plane. So deriving the formula to determine the center of pressure, to determine the locations of center of pressure, so we can use this equation and this equation. So after derivation, we obtain the final equations as Hp is equal to Ig sine square theta over AHG plus Hg, where Ig is the second moment of area, theta is the angle taken from the free surface to the object. Yeah, this is theta. and the rest is already explained before. Yeah. The second moment of area or Ig can be obtained by using this equation depending on the shape of the plate, whether it is rectangle, triangle, BHQ over 36, circle, pi r4 over 4, and semicircle 0.1102 r to the power of 4. Example 1. A rectangular plane surface is 2 meter wide and 3 meter deep. It lies in vertical plane in water. Determine the hydrostatic force and the location where it acts. When the upper edge of the plane for the first scenario coincide with water surface, and for second scenario 2 meter below the free surface. So let's look at the first scenario where the top of the plane is coincide with the water surface. So we know the Fr is equal to rho g A H g. So we have to determine the area. 2 times 3 meter is 6 meter square. And the Hg is half of this 3 meter. So it is 1.5 meter from free surface. So we can obtain the hydrostatic force F as 88.290 kilonewton. Whereas to determine the location where it acts, or HP, we can use this equation. So we need to find the value for Ig. As this is a rectangular, so we can use BH cubed over 12. We got it 4.5 meter to the power of 4. And as the plane is vertical, so the angle here is 90 degree. So we can substitute this into this equation to obtain the value for HP as 2 meter from free surface. Whereas for the second scenario, where it is located 2 meter below the water surface, when we want to calculate the Hg, we have to add up with the uh, depth above the upper edge of the plate, which is 2 meter. So we got the Hg to be half times 3, which is 1.5 plus 2, becoming 3.5 meter from free surface. The area remains the same, 2 times 3, which is 6 meter square. So we can say that when we place the plate lower into the water, so the resultant force acted is actually much higher. Let's look at here. The resultant force is 206.01 kilonewton compared to when the same plate is coincide with the water surface, the hydrostatic force is only 88.29 kilonewton. So the value is quite double. Yeah. Whereas for HP, so Ig remain the same, theta remain the same. The difference is only the value for Hg, which produced the final value for Hp as 3.714 meter from free surface. Okay, let's move on to the hydrostatic thrust on curved surface. In many structures of practical application, the submerged surface are not flat. The easiest way to determine the resultant hydrostatic force acting on a curved surface is to determine the horizontal and vertical components separately. Remember this, where we can obtain the resultant force by using theorem Pythagoras theory. Same goes when we want to resolve the resultant force into x and y direction. We can use this equation depending on which angle is given in the question. So whether it's theta or alpha. So to determine the value for fx, given the f is a known value, so fx is equal to f cos theta or f sin theta. Whereas for fy, it can be obtained by using f sin theta or f cos alpha. And theta can be obtained by using this equation, tangent inverse Fy over Fx. Consider an immersed curved surface subjected to water pressure as shown below. So horizontal component can be obtained from this derivation. So Fh is equal to rho g Hgav. So what's different here is actually AV, which is the vertical projected area of curved surface. So even though it is a curved surface, for the area, we have to take it as a vertical projected area. Yeah. Whereas for the vertical component, from this derivation, we obtain the final equations as Fv is equal to rho GV, where the V here is the volume of water prism, which is equivalent to the weight of the liquid. Note that the vertical surface of the liquid block considered is simply the projections of the curved surface on a vertical plane, and horizontal plane surface is the projections of the curved surface on a horizontal plane. Yeah. So the resultant hydrostatic force, when we already know the value for Fx and Fy, it is F resultant is equal to horizontal force squared plus vertical force squared. Yeah, it is a square root of this. This force act at an angle theta, which is equivalent to tangent inverse F vertical divided by F horizontal. And this theta is taken to the horizontal or the from free surface. Okay, if the surface displays the liquid, the term V in this equation to determine the FV is actually the volume of liquid displaced by the immersed curved surface. So no matter whether it is a surface containing liquid or surface displacing liquid, the volume taken is the volume above the curve, whether it is the volume of liquid or the volume of the liquid displaced. So the V is remain the same. Let's look at this example. Let's find the magnitude and directions for the hydrostatic force at vertical plane AB, horizontal plane CD, and curved plane BC. Okay. For surface A, we know that the height is 3 meter and the breadth is 1 meter, so it is 3 times 1. Hg is taken half from this depth, which is half of 3 meter, is 1.5 meter. So the resultant force can be obtained as 44.145 kilonewton. To determine the HP, we have to know the Ig, which is BH cubed over 12. So B is 1 meter, H is 3 meter. So H cubed divided by 12 is 0.75 meter to the power of 4. So we can obtain the HP as 1.667 meter. So this is for the vertical plane AB. For horizontal plane CD, so area would be 2 meter times 1 meter, the breadth of it. Hg is equal to 3 meter plus 2 meter as it is a horizontal plate. So 5 meter. So resultant force can be obtained by multiplying this and we got it as 98.1 kilonewton. In this case, HP is equal to Hg because it is horizontal. So it is equal to 5 meter for surface CD. Whereas for the surface BC, bear in mind, we need to determine the horizontal and the vertical component of it first. So F horizontal can be obtained by using rho G AVHD. So imagine that this plane here is vertical. So AV is 2 meter times 1 meter. Hg is equal to 3 plus half of 2, which is 4 meter. So F horizontal can be obtained by using this, and we got it as 78.48 kilonewton. Whereas for the vertical force, we can use this equation to determine the weight of the liquid displaced. So Fv is equal to 182.136 kilonewton. Bear in mind, we have to determine the resultant force. So we have to use theorem Pythagoras. Fh squared plus Fv squared Take it as a square root and we got it as 198.325 kilonewton. And the directions tangent theta is equal to Fv over Fh. So theta is equal to tangent inverse of this, and we got it to be 66.7 degree to the horizontal. That's all for the topic of hydrostatic force. Please go through the slides that I have shared to go through more examples on questions related to this subtopic. Thank you very much.